Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid bin Abdul Jalil, together with my team, which is Afiq Lufi bin Muhammad Azmi and Muhammad Adam Hakim bin Muhammad Zaidi. We will be presenting of Lab 3 Ece521 and we are from groups EE223 3B. First of all, the question that our team got is question 3. The question 3 have 2 input and 1 output. For the input, we have 2 switch, which is PB1 and PB2. PB1 is the external switch and PB2 is the internal switch in STM32 board. And the output is motor. This is the M1. And this is the table of the condition of 2 switch for motor movement. The first condition, when the PB1 is not pressed and PB2 pressed, so the motor M1 rotate clockwise in 3 and 6 seconds. For condition 2, PB1 will press and PB2 not press. So the motor M1 rotate anti-clockwise in 3 seconds. When the both switch press, so the motor M1 rotate clockwise and anti-clockwise continuously. Next, we go to the schematic diagram of these labs. First of all, we have the microcontroller of STM32F446RE, and we have 2 inputs, which is PB1 and PB2. PB1 is the external switch and PB2 is internal switch. PB1 connected to the PC5 and PB2 connected to the PC13. And as we know, this is the pull down resistor and the switch is active high. When we go to the output, which is we have one motor, which is M1. As we can see, the motor driver that we use is L293D, and the IN1 and IN2. IN1 connected to the PC9 and IN2 connected to the PC10. And we use the motor. This is one the motor, and the motor is active high.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afiq Lufi bin Muhammad Azmi, and I will be explaining about the configuration table for Lab 3 question number 3. So first of all, we will go to the RCC underscore AHB1ENR table. So the reason we do this table is to enable the ports that are used in the program. So for this program, we will be only using port C for both switches and for the motor. So we will enable the port C by putting the value number 1 on GPIOC, which is on bit number 2. So after that, we will get the value of 0x00000004 for the table RCC underscore AHB1ENR. So we will go to the GPIOC underscore model, which is for the input. There is PC13, which is button number 2, and PC5, which is button number 1. So we have to enable the PC13 and PC5 first. So for to enable PC5, we will go to the model 5 and put 1 and 1. And then we will go to the PC13, which is for button number 2, and we will put the value 1 and 1. This is for BIC, which is why we have to put 2 ones on 1 ports. So then we will get the value for BIC, which is 0x0C000C00. And then next we will go to GPIOC underscore model for the output, which is the motor. Note that there is two ports for the motor for in 1 and in 2, which is PC9 and PC10. So for the model output, we have to do BIC and ORR. Sorry for the typo. So so we have to enable in 1 first, PC9, which is here, model 9 for BIC. So we have to put 1 and 1, and then we have to enable into, which is PC10 here in model 10. So we put the number 1 and 1. So the value for BIC, we will get 0x003C0000, and then we will have to do for the ORR. So for the ORR, we do the same, which is we will go to model number 9 and model number 10, which is in 1 and in 2, PC9 and PC10. So but the difference for ORR is we will put 0 and 1. So here we can see that for model 9 we put the value 0 and 1, and for model 10 we will put the value 0 and 1 to enable the ports for the motor. So lastly we will get the value 0x00140000. Then we will go to the input GPIOC underscore IDR. Note that the switch buttons is active high, because it is in the schematic, it shows that it is the pull down resistor. The resistor is close to the ground, so means that it is active high. So first we will do the masking. For the masking part, we will show that we have to enable the ports that we use, which is PC5 and PC13. So to enable it, we have to put the value 1 on IDR5 and IDR13, and then we will get the value 0x00002020. And then we will go to the first condition, which is the PC13 is on. So to show that PC13 is on, we have to put the value 1 on IDR13 because it's active high, and when on condition 1, PC13 is on and PC5 is off. So when it is off, we have to put the value 0. So the value we will get is 0x00002000. So for condition 2, the PC5 is on and the PC13 is off. Okay, so I forgot to mention that PC13 is switch button number 2 and PC5 is switch button number 1. So in condition 2, PC switch button number 1 is on and switch button number 2 is off. So to show that it's on, we have to put the value 1 on IDR5. To show that it's off, we have to put 0 on IDR13. So lastly, we'll get the value 0x00000020. And lastly, on condition 3, where both buttons are on or are pushed, we will put the number 1 on PC13 on button 2 and the value 1 on PC5 or button number 1, because it is on. So we will get the value 0x00002020. So we will move to the GPIOC ODR. The ODR is for the output conditions. So for condition 1, it is shown that the motor spins clockwise. So to get the motor to spin clockwise, we have to put the value 1, value high on ODR9 or on port in 1, which is PC9. So when we put PC9 with the value 1, we will get 0x00000200. So, and then next we will go to the condition 2, which is when motor 1 is anti-clockwise. It will spin the opposite, or from right to left. So to do that, we have to turn on to put high on in number 2, which is on PC10 and on ODR10. So we have to put ODR10 the value 1 to show that it's high. So then we will get the value 0x00000400. And lastly, on condition 3, when motor 1 rotate clockwise and anti-clockwise continuously, it is when the motor spins clockwise first, and then it will spins anti-clockwise. Yeah, it doesn't have any stop lah, so it just spins clockwise and anti-clockwise continuously. Okay, so to show that, we first have to do motor 1 spin clockwise first, which is on ODR9 or all on in 1. We will put the value 1 to make it spin clockwise, and we will get 0x00000200, and then we will make it spin anti-clockwise, which is on in2 or on PC10 on ODR10. We will have to put the value 1 on ODR10. So we will get the value 0x00000400. So that's all for the configuration table for Lab 3 question 3. Thank you.
Hello, Assalamualaikum. My name is Muhammad Damakim. Today I will present about Lab 3 flowchart for this motor situation. So first of all, the program will start and the microcontroller will enable port C only by RCC HB1 ENR. After that, it will configure port C9 and port C10 as the output by the GPIOC model, and also then it will configure port C5 and port C13 as the input for the switches by GPIOC model. After that, it will start to read the value from both internal and external switches. So we check for the first condition, both push button and both internal and external button is pressed. The motor will alternate between clockwise and anti-clockwise continuously every 300 milliseconds until it detects that both switch is not pressed or either one of them is pressed. If this condition is not fulfilled, then it will proceed to check for another condition, is push button 2 equal to 1 and push button 1 equal to 0, which is the push button 2 only pressed while push button 1 is not pressed. So if yes, the motor 1 will rotate clockwise in 6 seconds and stops with 200 millisecond pause. The pause is to check whether the value from the switches had been changed or not. So if it's still not fulfilling these two conditions above, we will check for the last condition, is push button 2 equal to 0 and push button 1 equal to 1. If it's fulfilled, then motor 1 will rotate anti-clockwise for 3 seconds and stops with 200 millisecond pause to do for the checking, to check back the value from both internal and external switches if there is a change between the value. If it's not, then motor 1 will stops and it will keep reading back until the user wants to end the program. So that's all from me. Thank you for listening, madam. Assalamualaikum.
And now we go to the coding with explanation. First of all, we must include the STM32F4XX.h, and we must define all the function we use, which is the void delay ms, void motor CW, void motor ACW, and void motor stop. And in the main function, we have the RCC AHB1ENR with the hexadecimal 0x00000004 and GPIOC model VIC 0x003C0000 and GPIOC model or 0x00140000. And this for the GPIOC model for input, which is 0x0C000C00. And we go to the while one, and this is the coding for this one for the case 3, which is post button press. This one is the coding, and this is the GPIOC IDR. And we use the delay. This one for the delay for clockwise and delay for anti-clockwise. And we go and motor stop. And we go to the coding for the case 1, which is the only internal button press. This one is the motor will rotate clockwise with this delay, which is delay ms 6000, and motor will stop with delay ms 200. And this we go to the case 2, which is the external button press. So the motor will rotate anti-clockwise with delay ms 3000, which is, as we know, is 3 seconds. And for the motor stop, we delay 200. And else motor will stop. This is the motor function reference. This for the CW, which is clockwise. This function for the motor when it rotate anti-clockwise. This is the ODR, and this one is coding for the when the motor stop, which is the ODR. And this the function of delay ms as we define at the above, and this one the function reference. That's all from me.
Okay, Assalamualaikum. Here is the hardware demonstration for lab 3 and question 3. First, I will give the input, the two inputs that we'll be using. This is PB1, which is an external switch, and this is PB2, which is the switches on the board. And here we have one output, which is the motor. Okay, so I will be demonstrate for PB2, which is the user switch, the board switch. If I press it, the motor will spin clockwise for 6 seconds. Okay, 1, 2, 3. As you can see, there is a little bit extra seconds on the stopwatch, but we can prove that it is in the 6-second range for PB2. And for the second condition, which is when I press the external switch PB1, the motor M1 will rotate anti-clockwise for 3 seconds. So 1, 2, 3. Okay, so we can see from the stopwatch, it is also in the 3-second mark, which is proof the second condition. And for the third condition is when I press PB2 and PB1 simultaneously. So when I press both switches simultaneously, the motor will spin clockwise and anti-clockwise continuously. So here it is. Okay, so that's all for our hardware demonstration. Thank you. So, in conclusion, this experiment successfully demonstrated the control of a DC motor using the STM32F446RE microcontroller and the L293D motor driver based on the conditions of two input switches, which is switch push button 1 and push button 2. The motor rotated clockwise for 6 seconds when only PB2 was pressed. Then, the motor rotated anti-clockwise for 3 seconds when only PB1 was pressed. And finally, for the last condition, the motor alternately continuously between clockwise and anti-clockwise rotation when both switches were pressed, as specified in table Q3. So the rotation times measured using a stopwatch closely matched the program delays, confirming correct GPIO configuration, accurate timing control, and proper operation of the L293D driver. Overall, the results verified the effectiveness of switch-based motor control and enhanced understanding of DC motor interfacing with the microcontroller.